So this is exercise question number 1. The figure below is a diagram showing a stone of mass 2 kg that was pushed up a slope from Q to R. So from Q to R, as you can see, from this point, okay, which is QR here, from Q to R like this. As you can see, this is Q, which is the ground, and this is a point R, which is the top. Then we have S here, which is the midpoint of the height, and T is the base as well. So the question is saying that 72 joules of work was done in moving the stone up the slope from point Q to R. So from Q to R, so which means the energy used or work done was 72 joules. So we need to know that work done is always equal to potential energy, which is equal to kinetic energy. This is all about the law of conservation of energy. So, and we need to know that when the stone reach halfway, which is this halfway, the potential energy will be equal to kinetic energy. So, for example, this stone here, as you can see, it has what we call the gravitational potential energy. So the energy will be called gravitational potential energy because the object is raised above the ground. So this stone here, it has a gravitational potential energy. Then on top here, the potential energy is maximum. Then the kinetic energy is 0. So as the stone start dropping here, for example, when the stone reaches halfway here, this halfway, which is point S, the potential energy will be equal to kinetic energy. So for example, this is 72. So when divide 72 divided by 2, we'll get about 36, which means here potential energy will be 36 and also kinetic energy 36. Then as the stone passes the middle point, which means this stone now will have more kinetic energy and less potential energy. Okay, so now let me go back to the question. Question A is saying that what is the potential energy of the stone at R? So at this R, as you can see, since the work done, as I said, is equal to the potential energy. So the potential energy at this point will be equal to the same 72. So the answer for part A, answer for question A, part A, question A, the answer will be 72 joules. Yeah. Then now the next question is saying, if the stone falls through side RT, which is RT here, okay, what would its potential energy be at S, the midpoint of its hill? So even if the stone uses this point, I mean this root QR or TR, the energy will still be the same. So since the total amount of energy, as I said, is 72 joules, which is same as potential energy, kinetic energy, and work done. So when this object or this stone reaches halfway, so the energy will be half. So which means our question B, our potential energy now at this point will be, say, 72 divided by 2. The answer will be 36 joules. That will be the answer there. The question C. Question C is this side. You see the question is saying, calculate C1, the height TR. So they wanted to find TR, the height TR. So TR, the height TR, which is the height TR. So this height TR. So the way I'm going to solve this one, TR, this formula that we can use, let's say, so I'll say, since I have potential energy is equal to mgh. So my potential energy, as you can see, is 72. So write 72 here is equal to the mass, as you can see from the question, it is 2 kg. This 2 kg. So I say 2 times gravity is 10. We know this gravity is always 10 on Earth times the height, which is x here. So 72 equal to 2 times 10, which is 20, then h. Yeah, since I'm finding h here with mathematical concept here, I'll say over 20 and over 20 here. Then I'll divide. So I'll say height. The height is equal to, so I'll divide on the calculator. I'll say 72 divided by 20. The answer is 3.6. So the answer is 3.6 meters. This is my height. Height what TR or RT from here to here. Okay. Then I'll move to the next question. Question C1. So I'll go to question C2. It's saying that find the velocity of the stone just before it strikes the ground. So they want us to find the velocity. Okay. So this is C1. So C2, I do it from here. So C2, they want me to find the velocity. So the formula for velocity here that I can use, I'll say velocity is equal to square root of 2 gravity times height. This is a formula for velocity. So V stands for velocity, which is the speed. So the velocity is equal to the square root of 2 times the gravity is 10, as we all know. Then times the height, the one that I've calculated here, which is what, 3.6. So I'll put 3.6 meters per second here. So I'll say velocity is equal to, so I need to part now on the calculator. So I'll say 2 times 10 times 3.6 is 3.6. 3.6. The answer is 72. The square root. So V is equal to the square root for this one now. So I'll say the square root of answer, which is 8.48528137.4. So I'll say therefore the velocity is equal to, correct one decimal place, so it will be 8.5 meters per second, like this. So this will be my velocity.